Hi there guys, and welcome to another video with Science Sidekicks, and we're here again in Tinkercad where we're able to play around with electrical circuits that we've built and also experiment with controlling them from our Arduino. So if you saw my last video, it was explaining what a transistor is, and we were using a transistor connected to control pin number 2 to allow us to control a string of LEDs and turn them on and off. So these LEDs are all in parallel, so each one of them is getting the same amount of power, and they are being controlled by this single transistor here, which is connected to pin number 2, as I said, and that allows us to control this. So the reason why we don't connect this directly, we could go directly from pin number 2 to the power input of our power rail there, but we would be putting too much power onto that I/O pin to run all of these LEDs. So that's why we're using the transistor. If you want to know a little bit more about that, go over to our last video about transistors. The link is in the description below. So what we're looking at today is resistors and their effect on the circuit. So we have resistors here, and each one of these resistors has a different value, and we're going to see the effect of that. So now if we press start simulation here, you'll see we are now getting the LEDs flashing on and off, but you'll see that the one on the right is much brighter than the one on the left. And that is simply because each one of these has a different resistor with a different value to it. Okay, so interesting to note here, you can see the amount of current we're drawing. So when this turns on, we are pulling 29.7 milliamps. Okay. Now, if we were to change these resistor values, so at the moment, we start with 200, and we go 400, 800, 1.6 kilo ohms, 3.2 kilo ohms, 6.4. So basically, we've doubled the resistor value on each one. And you'll see that it basically kind of halves almost the amount of light we've got coming from the LED there, kind of, on each one. Now let's change these values. So if we were to set all of these to be, let's say, 100 ohms. Just take a guess before we actually do this. What do you think the effect is going to be on the LEDs if we reduce the resistance of each one of these resistors? What do you think is going to happen? And the other question I would have is, what is going to be the effect to the power draw? So not only is something going to happen to the LEDs, but something's going to happen to the amount of milliamps of power that we are using. So if we reduce all those resistors now to 100 ohms and we start our simulation again, now we've got a couple of things happening here. One, you can see we're using a lot more current than we were before. So we're up to 170 milliamps, and we've got this little warning here. So Tinkercad is smart enough to know that we are probably exceeding the amount of current that this LED can handle, okay? The maximum amount of milliamps. So we need a higher value resistor here to reduce the amount of current that the LED is drawing. So we now know that 100 ohms resistor was too small. 200 ohms was okay. So if we set them all to 200 ohms instead, obviously now the LEDs are going to get less bright than they were before, and our power consumption is going to go down. So in answer to the question I asked earlier, the two effects of changing the resistor values is it changes the brightness and the amount of power we're using. So the brighter the LEDs, the more power we use, so the higher the number of milliamps we see being consumed on our power meter. And the higher the resistor value, the dimmer the LED is, the less power we're using. So let's check this out now. So with them all set at 200 milliamps, you see we're peaking at, with all the resistors set at 200 ohms, we are now peaking at 88.6 milliamps. We are not exceeding the maximum current of the LEDs, and they are all lighting up to the same brightness. So what we've learned here is that by changing the value of a resistor in the circuit to the LED is we can adjust the brightness of this LED. So if we wanted a string of LEDs to all have different brightnesses, but we only have a single voltage source, we can put different value resistors in line to here. And using Ohm's law, we're actually able to calculate the voltage across the resistor, the voltage across the diodes based on the resistor values that we've got here and the currents across the diodes. So in future videos, we'll be looking at Ohm's law and how you can use that to actually calculate the correct resistor value for your circuits. But for now, we're just basic introduction to what the resistor does and its cause and effect. So you can see the effect of increasing the resistor value is that it decreases the brightness of the LED and decreases the amount of current that we are consuming. So thanks for tuning in. I hope you found this useful. Don't forget to like and subscribe, and I'll see you in our next video.